morning. I'm Dr. Mustansar, and today we would be going through recommender systems, which is extremely important area and application of AI, and it is helping web giants to make loads of money. And I hope with this video you can get some flavor of recommender systems. Let me share my screen. I hope you can see my screen now. So let's start. Okay, so recommender systems, basically they are artificial intelligent assisted tool. I am Dr. Mustansar and I am assistant professor. Let's open our discussion with a cup of coffee because this is a morning time and I can see a lot of you there like this. And we want to make you like this one, a big smiley, okay? And I hope coffee will give you a flavor to boost to that smiley. Who likes coffee, by the way? Ah, Hannah. Good. Okay. Well, this talk is about Hannah, and this is Hannah's childhood. She is a very cute kid, as you can see from the picture, and she is confused over the huge variety of the information, and she is saying, "Hey, how to choose my taste? I want to have my favorite coffee, but how I can choose the taste from millions of items over the web? And should I try each and every flavor and then adjust to one saying, hey, that was the right flavor I was searching for? No, you might have to wait 10 years for that due to the information overload. So the solution we propose is to use recommender systems. Okay, they will help you to find relevant taste. And of course, this is not limited to coffee. This can be any item. Okay. So Hannah use recommender system and it will help you to find your favorite taste. Okay, without going into details, this is today's agenda. I'm going to talk about types of recommender systems, okay, which are collaborative, content, and demographic filtering. And then there's a concluding remarks as well. So recommender systems, they are basically information filtering system which take users' opinion, their taste, their ratings, their votes, their voices into account, and based on that they build models, and based on the models they can recommend you certain items or the resources you would be love to consume, you would love to watch, you would love to buy certain items. So they are useful for you, they are interesting for you. There's a lot of applications area like Google ads, they recommend you relevant ads. Facebook and Amazon, they recommend you products. Netflix recommend you movies. YouTube recommend you videos. So the application spectrum is huge and they're gaining a lot of attention nowadays. So basically recommender systems, they have two relevant entities. One is users, which is on the left hand side, and one is item, which is on the left hand side or right hand side. When we say user, we can take gender of the user, the age of the user, and we can recommend product to the group of users as well. And we say item, we can take variety of information. It can be camera, or phone, or movie, or the partners in recent dating website, because if in the dating website they recommend you partners saying, hey, they are similar to you, so you might be interested in them. So when we say user provide rating about items. For this item, rating is very complex. Assume the user is angry, the rating pattern might goes down. So there's a huge context behind this rating pattern. Like if you're watching movie with some friends, you might give it more rating, the location of the cinema, and so on. So in this talk, I'm ignoring the contextual information. We assume that the rating you have given is the actual rating, okay? So there is no context because this would be difficult to cope in one lecture. So recommend certain product to the user. and the user give us feedback saying, hey, I like this product, thumbs up, or thumbs down, I hate this product. And this user feedback, we take that into account as well. And in fact, if you go to like Facebook and you hide any ad, they ask you why you have done that. So you want to take your feedback into account to refine those ads. Okay. So when a new product comes, we have two kind of information. One is the rating provided by other users to this product, and the second is the content, like the description of this item. For example, the focal length of this camera, the megapixel of this camera, the how it looks like, and so on. So based on these two kinds of information, we can recommend this to the active user. Okay, and in fact, we can recommend the top end recommendations saying, hey, you will like this item and you would give it 5-star. You will like this camera and you will like it 4-star, and so on. So this is just a snapshot how recommender system works. Now let's see the famous types, which are the collaborating filtering, content-based filtering, and demographic filtering. Okay, so I would be just touching them in this lecture. So before that, in Amazon, they recommend you items because you have purchased or viewed similar items. So this is also a kind of recommender systems algorithm. I have written some blogs which you can read. Let me show you at the end of the lecture. Let's go to the first type, collaborating filtering. So in collaborating filtering, you have some active user, the user you want to recommend something, okay? And you have a group or the community of user, which can be very diverse. It can have it can have the different age and genders and different demographics. So in the first step, we find the similar users to the active user, which are also called neighbors of the active user. Okay, and based on these neighbors' opinion or the votes, we can predict how active user will like or dislike a certain item. And in fact, to find the similar users, you have the profile of each user into the database as well. Okay, so based on these, we can make some similarity, let's assume vector similarity, and so on, and find the similar users. So again, you have an active user, and from the group of users, you find similar users, which are called neighbors. And from these neighbors, you take their votings into account and make some prediction based on the aggregate or the majority opinion. And to find the similar user, you have their profile in the database and you can match them easily. So from here, you have a user profile, you have an item profile, and you have a rating matrix. Okay, so usually this is like this one. You have user on one side, item on other side, and you have a matrix where you have the ratings. Okay, so these are the building blocks of recommender system. Usually user have a lot of users. Okay, user 1, user 2, and whatever. Item has the similar many items, item 1, item 2, and so on. Okay, and this user into item rating matrix is really big. There's a lot of missing. Excuse me. There's a lot of missing entities in these building blocks. So let's take some examples. So assume after your graduation you go to Netflix and they ask you to build a recommender system for them. Okay, they ask you to build a recommender system for them, and we want to see how a user is going to like or dislike a certain movie. So assume they give you these data sets. They say, hey, we have 4 users. So these are the users. John, Annie, Ali, and Julie. And they say they have 5 movies, okay, items. And they have certain information as well, where the rating scale is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 is excellent and 1 is pathetic. Okay, so if, for example, John has given Titanic 10, mean John likes this movie, and Triple X 8, somehow he likes this movie. Julie has given 1 to Titanic, so she hates this movie. So this is the data they have given you, and they want you to build a recommender systems using collaborating filtering. And they want to know how John is going to rate the god. Okay, how John is going to rate the god. So in the first step of collaborating filtering, which is also called user-centric collaborating filtering, you find group of users who have rated target movies. So here you can see Annie, Ali, and Julie. They have rated this item. So you take these item, which is the community of users. So these are the community of users. Now you want to find the similarity of these user with John. Okay, so you want to find similarity between John and Annie, between John and Ali, and between John and Julie. Okay, you want to find these similarities. And to find similarity between them, you can see the John's profile is this one. Okay, so this is a vector, 10, 10, 8. Okay, so this is John, and the Annie's profile is 10, 10, 9. So to find similarity between them, you can use any vector similarity. Vector similarity. Usually we use Pearson correlation because this is much richer. Okay, Pearson correlation. This is much richer similarity measure. So as I said, you find similarity between John and Annie, John and Ali, John and Julie. Okay, based on these profiles. So how you find similarity between them? There is a very famous measure which is called Pearson correlation, which is just here. Okay, so this is the formula where I'm not going into detail about that, but in NumPy you can simply say correlation coefficient and it gives you the similarity between them. For example, this is the code to find similarity between A and B, where they are the vectors, and the similarity between them is minus 0.57. So the output of this is between -1 to +1, where +1 mean highly similar, 0 mean not similar, and -1 mean highly dissimilar. Okay, so Pearson correlation gives you much richer information because it gives you dissimilar users, highly similar users, and not similar users. So based on this measure, similarity measure, you find similarity between John and Annie, and it turns out to be 1. You find similarity between John and Ali, and it turns out to be 0.5. You find similarity between John and Julie, which turns out to be minus 0.8. Okay, so they are very similar, and John and Annie, they are highly dissimilar. Okay, now the last step, you take the votes of the respective user, like you take the vote of John and Annie and multiply it with the similarity of John and Annie. So what you do, you take similarity between John and Annie. Okay, so this is the similarity between John and Annie, and you multiply it with the rating given by Annie. You take similarity between Ali and John. Okay, Ali and John, and multiply it with a rating given by Ali between John and Julie, and multiply it with the vote given by Julie. Sorry, here. And you divide it by sum of the similarity, and this is more like a normalization factor, so not very important, but we use it. it makes sure that the range of output is usually between 1 to 5. And of course, these are normalization factor. But the most important thing is you find the similarity between the active user and all the user, and then multiply the opinion or the ratings of those neighbors with their respective similarity, and you add them. Okay. So once you will do that, you will see the you plug in the values, you will see the prediction is 7.5. So this is not very surprising that this is 7.5, because the other users which are similar to John, for example, Annie, she has given this 10. So 7.5 is pretty close. And the users which are not very similar, Julie was highly dissimilar and she has rated it as a 1. Okay, so this is quite opposite. So 7.5 mean John is going to like this movie. Quite simple. As you can see, collaborating filtering is a brilliant algorithm, and it is extremely simple but very powerful. Now, a related algorithm is item-based collaborating filtering. This is quite similar to item-based, except now we reverse the matrix. Okay. Now, what you do, you find similarity between the God and different items. So you find similarity between the God and Titanic, the God and the Proposal, the God and XXX. Okay, and then you multiply the similarity with the respective weights. So everything is the same. In other terms, we find similar items to the target item. Okay, we want to find the items which are similar to the God, and then multiply those items with these weights, add them, and make the prediction. I'm not going into details, but you can figure this out yourself, that this is exactly the same, apart from you just take the transpose of the matrix. So this is highly powerful algorithm, item-based collaborating filtering. In fact, Amazon was using it a couple of years back. If I'm not wrong, in 2005 or 7, they were using much simpler version of item-based collaborating filtering. So this explains the power of collaborating filtering. It's very scalable. It's more accurate than user-based collaborating filtering. So I am pretty sure you would be getting more and more flavor of collaborating filtering in coming lectures. But the idea is they are very, very powerful. On the plus side, they are simple algorithms and they use wisdom of crowd. Like, as you can see, you have a couple of peoples and the votes of individual does not count. But if you combine them, it becomes very powerful. So it's a social, intellectual, social filtering of the votes. And they give high accuracy recommendations. Their accuracy is really high. But in sparse data where you have a lot of missing values, okay, if you have a lot of missing values, the accuracy of those matrices might suffer. In those settings, in sparse settings, you usually switch to second type, which is content-based filtering. Okay, so now let's go to the content-based filtering. In the content-based filtering, you go to the content of the item. Like in coffees, you see the bean quality, their quantity. If this is a movie, you go to the genre of the movie, the actor and actresses of the movie, the reviews of the movie, the tags of the movies. And based on those, you build profiles. Okay, and then you can use different classifiers like K nearest neighbor, sport vector machine, neighbor base, and so on. And then you can recommend or predict any item you want to. In Amazon, you might have seen similar item scenarios, and they might be using the content-based filtering for that. So let's take an example. So here is a user, Hannah, and she wants to see how, and we want to build some system for that. and he has rated certain items, movies. Okay, so the movie 1 contains romantic, horror, Keira Knightley. Item 2's description is Hollywood drama and Julia Roberts. Item N is Emma Watson, Tom Hardy, and it's an action movie. We feed Hannah's profile into machine learning model, and they capture certain latent information of Hannah. Let's assume there's a new movie target item, which contains the description of that item contains Emma Watson, drama, and sci-fi. Okay, and we want to see how Hannah is going to react to this movie. So we feed this to the classifier. Now classifier based on these two make some fancy matching and mathematical models, and they can recommend it. So what do you think is gonna like or dislike this movie? From here you can see Hannah is going to like it because it contains Emma Watson, and somehow Hannah likes Emma Watson. It's a drama and she likes dramas. So you get the basic idea that machine learning classifiers, they capture the important features, textual features, and then they can match it somehow. Of course, this is not that simple, but this gives you some flavor of that. And of course, in actual machine learning, you convert them strings, you convert them into some numeric values, okay, plus numeric values, +1, +5, -6, and so on. And then you feed them to machine learning classifiers. So actually, this is much complex as compared to how I have explained, but somehow you get the basic idea. Advantages and disadvantages of collaborating filtering. You can explain the recommendations as well. Like here, we can explain to Hannah that why she has been recommended this movie. Okay, because it contains Emma Watson and you like Emma Watson. But the negative side is usually it's difficult to get meaningful features from the data, like from the multimedia data. It's not easy to capture the information like speech and so on. So it's hard to capture this information. The last type is the demographic based recommender system, which is quite easier. Assume you have these items, okay, in the database. And this is especially good for retail websites like grocery website, Asda and Walmart and Tesco. Assume there's a couple of users and two users, they have similar features. So what it analyzes that there is a user who likes item C, but this item has not been seen by similar users. So why not recommend this item to this user as well? Okay, so you somehow get the idea that if there are users who have same features, why not recommend each other's product to them? So here in this case, both are male in their 20s. So if this is a t-shirt, assume, why not recommend this to this guy as well? So this is just an example, but of course, in the actual framework, demographic might include postcodes, gender information, age. It might contain the certain college they go, and certain other tastes they share. And of course, they can be done for the items as well. For example, in the movie case, certain movies, they are romantic. Okay, so romantic is more like a demographic feature of movies. And so again, in demographic based filtering system, you use certain demographics of users and items. And based on that, you can recommend to different users certain products. Okay, so that's it. I think we have done today's lecture. So the first type is collaborating filtering, of which take the users community into account, or the items community in case we are working with item-based collaborating filtering. Content-based filtering, they take the content of the information and they build some machine learning classifiers. Demographic take uses demographics like age, location, and so on. And in actual framework, they build hybrid recommender systems. which is a combination of all of them. So I hope you get the basic idea of a recommender system. Now a relevant question is, for example, which algorithm is being used, let's assume by Amazon. So a couple of years back, I was with a discussion with Amazon guys, and I came to know that they are using different kinds of information, like they are using collaborating filtering, the content-based filtering, they are using SVD, matrix factorization. So they are combining all of them somehow in the traditional algorithms, and then they were recommending it because this is more plausible to explain if you use these kind of applications, algorithms. And one of their group, they were working on neural network and advanced algorithms like reinforcement learning. So they have two groups. One group is working on advanced algorithms, because in advanced algorithms, like in neural network, it's hard to explain why you have been recommended certain item. And the other group is working on the conventional algorithm, but they are combining it somehow. So I would give one more lecture some other time about Amazon and what are the pitch drawbacks of Amazon recommender system, and you will get more idea about that. Thank you very much. And these are the books. I would be recommending to read this book because this is really good machine learning book. Collective intelligence is good as well, and this is advanced. So this is the preferences you should be following, and the PDF of this is available as well. Okay, you can download is as well. Thank you very much, and please keep safe. If you have any question, please let me know, and I would be happy to help. Okay, thank you very much, and see you next time. Bye bye.